Good morning, everyone. We are ready to tackle surface area today. And as we do this, I don't ever want you to be overwhelmed, but I want you to remember the message of my shirt today. We can do it. We are like Rosie the Riveter, and we can do this, okay? There's nothing too difficult, and this is not difficult, but it can seem overwhelming because it can seem large at first. But as we break it down into pieces, it's pretty simple. But the first thing we have to remember is how it is that we find area in the first place, which we already talked about that before. Okay, so of a 2D figure, a flat figure, how do I find the area? And remember that the area was, let me make sure I have just a second. Okay, remember area is length times width. Okay, length times width, and so we're just going to take one side times the other side. So here it's 6 blocks this way and 2 on the side. So it would be 6 times 2, which would be 12 inches. And whenever we do area, we have to remember that we put the square sign here, inches squared. So for this one, 12 times 6 would be 72 feet squared, right? And then this would be length times width, 10 times 10, which is 100. And this is 12 times 9 yards, which would be 108 yards squared. Okay, so now we're going to figure out, so if that is how I find the area of a flat figure, a flat shape, then how do I find the area of a 3D shape? And really the key lies in making your 3D shape 2D. So what you do is you take, so here's my box, okay? Here's my 3D shape, my ice cream cone box. But I want to find the surface area. Now surface means outside, right? So I need to open this 3D shape up and look at it as a flat figure or a net. Remember, it's called the net of a 3D figure. So I take it and I need to kind of open it up in my mind if I can't do it physically. And that's what they've done here on this paper. Okay, so they've taken this big figure and they have basically cut it open and laid it open. And you need to make sure that you have all 6 faces, right? Now, some of those faces are going to be the same. So if I have a rectangular prism, then the ones that are opposite, that are parallel, are going to be the same. So if I open this up, okay, then this one down here, like they have, this is A. Right? So A is, when I have my box closed, is parallel to this one. So that means they're equal. So this is B, just like I'm labeling it the same as your paper. So this is A and this is B, and these are going to be the same. Okay? Now, what are the other two that are the same? This one and this one, these are the sides, aren't they? So here and here. And on your diagram here, that is labeled C and D. And then these little ones on the side, this is the height. This is the top and bottom of my box. And so that is going to be E and F. Okay? Now, to figure out the surface area, all I have to do is find the area of each individual section. So I want to find the area of A. I want to find, and that's going to be the same as B. I want to find the area of C, and that's going to be the same as D. And then I'm going to find the area of E and F, and you have to have all 6, and you add them all up together. Okay? So for mine, if I were to find the area of A, I would in inches, want to find the length, which is 10. And then I want to find the width, which is 7. And I would do 10 times 7, which is 70. And A and B would both be 70. So I would have two 70s. Okay, two 70s. Then I would have to figure out C. Okay, and on mine, C would be 10 by, I'm going to round by 2. 10 by 2, which is 20. That means that D would be 20. And then I would do E and F, and that would be 7 by 2. So 7 times 2 is 14, and I would have two 14s. So to figure out the surface area of my entire box, I would just have to add all of those numbers. 70 and 70 is 140. 20 and 20 is 40. 14 and 14 is 28. I would add all those together and get 208. So 208 inches squared would be the surface area of this ice cream cup box. Okay, so let's figure out the surface area of the rectangular prism that they give you on your paper. Okay, so we're going to start with blue, which is A and B, and that's here and here, and they're going to be the same. So if I look, there's 12 cubes this way, and there's 8 cubes going back this way. So I would do 12 times 8, and then I would come down here and do that again. 12 times 8. 12 times 8 is 96. So this one would be 96. Okay. Now let's do C and D, the orange one. That's the side here. So I know that it's 12 long and how wide? 2. 12 times 2, 12 times 2, 24, 24. Now I need to do E and F. That's the height here. So it's 8 long times 2 high. 8 times 2 is 16. 8 times 2 is 16. Now I simply need to add all those together. So 96 plus 96, that's the top of the bottom, that's the blue. 24 plus 24, that's the front and the back, and the sides are 16 plus 16. Okay, so 16 plus 16 is 32. 24 and 24 is 48. Okay, so if I add those two together, which I want to do because 8 and 2 make a 10, then that would give me 80. Okay, now let's add 96 and 96. 6 and 6 is 12, so the last number is going to be a 2. 9 and 9 is 18, plus 1 is 202. Did I do that right? Nope. 18 plus 1 is 19. 192. Yeah, 192. So 192 plus, I added those two before, that's 80. Okay, so 192 plus 80 would be 272. 272 inches squared. So all we did, length times width, length times width, length times width on every part of our net. Okay? Now let's practice down here on this one. Same thing. So I would encourage you, if you understand, to try to do this on your own and then check back, unpause the video, and then see if you got it. So they actually do this really easily because they give you the answers here. So 9 times 3 is 27, and if we understand that top and bottom are the same, all we need to do is repeat that. So 9 times 3 is 27. They've given you the measurements for front and back, which is 9 times 6. 9 times 6 is 54. So we're going to write that in there twice. They've already given you the right side. And now the left side is going to be exactly the same. 6 times 3 is 18. Now we simply add them together. So 2 27ths, 27 plus 27, 54 plus 54, 18 plus 18. And 18 plus 18 is 36. 54 and 54 is 108. And 27 and 27 is 54. So I'm going to choose 54 and 36 to add first because they have matching partners. 4 and 6 is a partner, and that makes a 10. So that's easy in my head, and that makes 90. And then 90 plus 108 is easy to do. That's 198. So 198 centimeters squared is the surface area of this rectangular prism because we just took each side. Okay, now they do another one. Now this is a cube. So a cube is really easy because we need the length times width of 1. And because it's a cube, these are the same. So it's, what is the area of one face of a cube? And it's 8 times 8, which is 64. What is the total surface area of the cube? So it would be 64 times however many of these I have. 1, 2, 3, 4, 5, 6. 64 times 6. So when I do 64 times 6, what do you get? $384. Okay, so what is the total surface area of this cube? The area of one face is going to be 3 times 3, which is going to be 9 centimeters. And then I've got 6 of those. So 6 times 9 is 54. Now, what are these dimensional figures? This is the net of a what? Here's the base is the one colored. So it is triangular prism because it doesn't come to a point. See how it's got the rectangles here? This one is going to come to the point, and it's got a square base. So it is a square pyramid. This one is a cone. This one has a rectangle as the base, so it is a rectangular what? Prism. This one is our oatmeal box, which is the cylinder. This one has a triangular base, and it's going to come to a point, so it is a triangular pyramid. This one is not ball, it's not circle, it is sphere. And this one is going to come to a point, so this is the net of the cone, right? If you were to cut that down. Draw the net of a soup can. So if this is a soup can, what would the net look like? Remember, it's going to have a big rectangle shape in the middle, and then it's going to have a circle at the top, and it's going to have a circle at the bottom, because the circles are going to come up like this, and then that big rectangle is going to wrap around the middle. If the bases of these two cylinders are congruent, how would their nets differ? So the circles are the same, but how would the nets be different? The nets would be different because the rectangle, spelled it wrong, rectangle would be taller, right? The circles would be the same, but the middle part is what is actually bigger there. So the rectangle in the middle would be bigger. Okay, now that you have looked around your house and tried to see some of these shapes around your house, I want you in the comments below to tell me which one of these dimensional figures that we have talked about is the most common in your house. Which one do you think is the most common? And because it's common, I expect to see a lot of the same answers. But explain to me what is the most common in your house, okay? Have a wonderful day.